So we're going to go over concavity and points of inflection. And what we're going to do here, is we're going to be figuring out that in order to find concavity and a points of inflection, we're looking for the second derivative of a function. So we know we can find the first derivative of a function, which we'll do, f prime x is equal to 3x squared plus 6x minus 9. And we know that this information here can help us. Okay? If we find our two roots, they'll give us critical points. Okay? They'll tell us when the tangent to this is horizontal, and it'll also tell us if it is increasing going up to that point or decreasing going down to that point. But one thing we don't really know about is if we're at a specific point on a graph. Okay? So say we found our critical points, whatever they would be in this case, and say one of our values is maybe -3. We're not sure if our graph is approaching it in this fashion, okay, which is increasing, or if it's approaching it in this fashion, which is also increasing. This is what concavity is going to help us with, so finding the second derivative. It's going to tell us how our sketch is approaching it. Before we were just kind of making arbitrary sketches, assuming we knew what they would look like. So our second derivative of the function gives us 6x plus 6. Working with, I've chosen this one because it's relatively simple to work with. We're going to set it equal to 0 because 0 is going to be an important value for us. So when f of x is equal to 0, we have 6x plus 6, and we have -6 equals 6x. X is -1. So this point here of -1, okay, when x is -1, is very important to us. What we're going to have to find is when x is equal to, or actually, sorry, our 3 points. We want to think around -1. So first of all, we want to find when x is equal to -1. We want to find when x is less than -1. And we want to find when x is greater than -1. All of these will give us either a positive, a negative value, or a value of 0. And we'll talk about values of 0. But specifically, we're looking more into things being positive and negative. If something is positive, then it's concave up. So in other words, it has this type of shape to it. Okay? If we have a positive. If something is negative, we have something that is concave downwards. Okay? And this is the types. These are the types of movement on a graph that we'll be inputting when finding out these values. So when we are less than -1, so approaching this critical point, let's find out. So what is a value less than -1? We'll put it on a number line so it's a little simpler for us to see. Our value at -1. Okay. So essentially we have a negative and positive infinity. These are our points. We're going to look at when x is -1, and we're also going to look at a value of 2 and maybe a value of 0, both being important. So when x is 2 and when x is 0. We'll put it into our second derivative function. So the second derivative of x minus 2 is equal to 6 times -2. I think it's plus 6, yes, plus 6. We're really just important whether this gives a positive or negative value. This will give us a -12 plus 6, so we get a negative value, essentially -6. So what this is telling us is our function is concave down at that point. Okay? So we have concave downwards. Our other point, and we'll go around -1 for now. We know -1 is going to give us an f of x at 0. When we are greater than -1, f prime 2, our point of 0 becomes 6 times 0 plus 6, which gives us a value of 6, which is a positive value. So we know at that point we are concave upwards at this point. What we also want to find out if we're increasing or decreasing at points when we go to sketch this. So this is important for us. Now we found if something is our concavity of it, we have to go back to some of the information we've learned from before and find our roots for increasing, decreasing. So 3x squared plus 6x minus 9. So 3x squared minus 6x minus 9 plus 6 minus 9 plus 6 minus 9. Okay. Let's common factor 3 out, and we know we're going to set it equal to 0. So we have common factor 3 away, x squared plus 2x minus 3. 3 disappears, and we can use positive 3 and negative 1. So we have x plus 3, x minus 1. So that means our x's are negative 3 and positive 1. So these are our critical values right now. So we're going to be doing the same thing with our number line to find increasing and decreasing points. We have the value of negative 3, positive 1. So we need a number in between. We can take 0. A number greater, we can take 2. And a number less, we can take negative 4. And we're going to plug those into our derivative function to find out when it's increasing and decreasing. So our f prime at negative 4 is equal to 3 times negative 4 squared plus 6 times negative 4 minus 9. 3 by 16 minus 24 minus 9. 3 by 16 is 30. Whatever it is a positive value. Okay? So what's important here is this is positive, therefore it's increasing before that critical value. Are we okay with that? No, it's got to be positive. So this is like 48, isn't it? Okay, so that's 48. F prime at 0, that's going to just give us negative 9. Okay, so we have a negative value, so we know we're decreasing between those critical points. And finally, f prime at 2 is equal to 3, 2 squared plus 6 times 2 minus 9. It's probably going to be positive. I'm just going to double check. That'll be 4, 12 plus 12. Yeah. So we get a positive value again. Positive here, so it's increasing. So let's take our rough sketches and see what we can do with them. We know we have critical values due to our first derivative's roots at negative 3 and positive 1. So at negative 3 and positive 1, we know we have tangents of 0. Okay? We also know that from negative 3, we're increasing. So we're increasing at this point. We're decreasing between them, and then we're increasing again. And due to our second derivatives, we know that we are concave, lost track here, negative 2. At negative 2, we were concave down, I believe. Yep, and concave up. So at negative 2, we're concave down and concave up at our critical value of negative 1. Okay, so negative 1 being our critical value here, which is here, at negative 1. So we were concave up first, was it? No, forgot already. Down, thank you. So we are concave down up to negative 1 and concave up to those points. So when we go to draw this, this was an increasing value. So it was increasing, and it got to at 3, we had a turnaround point. And we can find out what the exact values are by plugging in negative 3 and 1 into the original equation. And we probably should do that so we know where they lie on the at specific coordinates. So let's actually take those values. 3 cubed, 3x squared, 3x squared. I think it's minus 9. Yes, it definitely is. So we're going to plug in at f at x. We're going to plug in negative 3 and 1 to find out what the actual coordinates are at this point. It'll help us when going to graph this. Our first point being negative 3, so negative 3 cubed plus 3 times negative 3 squared. If anyone has a calculator, it can maybe help me out with this. And the other one, we'll find f at 1. That one will probably be a little easier. Cubed. Oh, I think it is minus 9. Let me jump up. Yeah, it is minus 9. Thank you. 3, 1 squared minus 9 times 1 plus 10. I'll do the one on the right. Is it 11? Which one? One on the left is 10. Okay. And then the one on the right, we have 1, 3. So we have 4 minus 9, negative 5, positive 5. Okay, so these are our coordinates, -3 and 10 and 5. So here's our coordinate, -3 and 10 and 1 and 5. Oh, it's not 10? It's 37? Okay, much higher, but still above, which is important to us. 37. Oops. So this being 37 now. We knew we were increasing to this point. So we're increasing but concave downwards, which means we have this type of motion. Okay, so it's concave downwards but still increasing. And then we know we're decreasing, but up until -1, which I'll give a different color intercept to. At -1 is when our concavity changes. So it's still concave down, but now decreasing. Say decreasing, decreasing. And then from -1 forward, it becomes concave upwards. So it starts to take this effect. And then at this point here, it starts increasing again. So we're now concave up, decreasing, 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 increasing, increasing, increasing. Okay? So I'll highlight where we're concave down in yellow. So we are concave down all the way to this point here. And then from -1, we were concave upwards. So that's what our second derivative does. It helps us draw the concavity of our function. And all of our other points become very important too, because they help us really put in place where in space this function is. So that was almost all 3 lessons tied into it.